Hi friends, I welcome you all to the course Marketing Research and Analysis. So, in the last class we discussed about the analysis of variance, correct. So, analysis of variance is a technique which is an extension of the t test, right, extension of the t test, where you were earlier able to compare between two groups, right. So, when a necessity occurred arised for comparing more than two groups or three levels, for example 3 levels or 3 groups, then such a condition a multiple t test seemed reasonably correct, but that had its own problems. The problem was that a multiple t test, as I have explained earlier, leads to a inflated alpha, that means that the type 1 error gets inflated because each time you take a 5% level of significance or whatever level of significance, that gets added up as you conduct a multiple number of t tests. That means, for example, as I had said earlier also, so there are 3 groups. So, if you have 3 groups, then multiple tests you will be doing t tests. So, that means what, 3 tests when you do each time 5% with a 5% level of significance, the type 1 error somewhere increases. So, to avoid that, we had one test called the analysis of variance. This test is a very powerful test and highly utilized in experimental studies, right. So, what is this test says is that whenever there are more than 3 groups or levels in a independent variable, and the dependent variable is metric in nature or continuous in nature, in such a condition that means y and x, y is my dependent, which is my let us say metric I am saying, and x is my is a categorical variable. So, let us say for example, I am trying to say the popularity of a car is dependent on the type of engine it is using. So, suppose there are 3 types of engines it is using. Now, this type of engine is leading to the popularity of the car. Now, that is what we want to suppose test. In such a condition, we would say that this is a case of a analysis of variance. However, if there is only one factor, you said there is, for example, I said here type of engine, right. Suppose I would say the nationality which country it comes from. For example, let us say again we have 2 or 3 or 4 whatever, right, we have 4 levels. Now, for example, Japanese, right, American, right, let us say Indian, let us say, and the 4th is Italian, let us say. So, suppose I am having 4 nations from which the car comes, and I feel the popularity of a car is not only related to the type of engine, but also to the type of the nationality that it comes from. In such a condition, we have 2 factors, one factor the engine and the other factor the nationality. So, we have 2 factors, so we say it is a n-way ANOVA, which is, or a 2-way ANOVA basically, it is a 2-way ANOVA, a 2, 3, 4 all together we say they are called type n-way ANOVA basically, okay. So, in the last class we also had discussed, in the same condition if you have a case where the dependent variable is let us say same popularity, and the independent variables is, one is engine, let us say engine, which is you have measured as 1, 2, 3, and the other is a continuous variable, another continuous variable which is your independent variable. Now, let us say what can it be, let us think. So, popularity is affected by the type of engine, and let us say the mileage the car shows, right, also leads to a popularity. Now, mileage is measured in a continuous variable. Now, these 2 things, you see, engine, type of engine and the mileage, they also could have a relationship also, right. So, in these 2, when I have a one independent variable as a categorical and the other independent variable is a covariate, which is a basically continuous variable, then a case of ANCOVA is used. A ANCOVA is nothing but a combination of ANOVA and a regression model, right. So, it is a ANOVA plus regression, as you can understand, you can see here. So, popularity is my, let us say is a dependent variable which is continuous, and engine is categorical. So, if you take up to this much, then it becomes a case of a ANOVA. When I am adding the dependent variable is metric and another independent variable is metric, then in that case what it becomes? It becomes a case of a regression. So, that is why I said ANCOVA is a case of ANOVA plus regression, right. So, today what we will do is we will try to solve some problems in hand by hand. In the last class we had solved a problem by hand for ANOVA. Today we will solve it, we will go a little further. Now, what is this analysis of variance? Let us understand in marketing condition. In marketing research, one is often concerned with the effect of more than one factor simultaneously. If two or more factors are involved, the analysis is termed as N-way analysis of variance. Okay. Take some examples to understand. Let us be first clear what N-way analysis of variance means. A study was done to understand the effect of brand of car, right, and tire on gas mileage. Now, what it is saying? The brand of the car, which brands, for example Tata in India for example, or the Hyundai car. So, what brands are you using, right, and the tires that you are using, how they affect the mileage. So, mileage is my dependent variable and the brand of car and the tire, which are both categorical in nature, are my independent variables. Another example, how do consumers intentions to purchase a brand or buy a brand vary with different levels of price and different levels of distribution. Now, my intention to buy a brand is my dependent variable, my independent variables are levels of price and levels of distribution, right. So, there are again two conditions here, two cases. I could have used a third also, maybe levels of price, levels of distribution and level of promotion, or in which media they are promoting, let us say promotional medium, so TV 1 or let us say radio 2 or print 3 kind. So, level of promotion I am saying. So, I may add 3 also or more n, right. Another case, how do advertising levels interact with price levels to influence a brand sales? So, something close to this one. Last one, does income level high, medium and low and age affect the consumption of a brand? Now, affect consumption of a brand is my dependent variable and these two are my independent variables. So, you see in these conditions we always have a dependent variable which is let us say continuous and the independent variables are categorical. Okay. Now, these are the assumptions in ANOVA. Each sample is randomly selected and independent, right. So, these samples are independent of each other, they should not be moving, it is not a repetition. So, if you want to do a repetition, then that is a special kind of ANOVA called repeated measures ANOVA, but here we are talking about that the samples or the respondents are independent, they will fall into one and only one group. Okay. Second, equal variances between treatments. Now, this is a very important assumption we say called homogeneity of variance. Homogeneity of variance. Now, it says it means that the variances between the different groups which you are trying to compare should be same, else they cannot be, they should not be compared, right. This is very popularly told as a Levin's test, right, which helps to measure the homogeneity of variance. And it is very interesting to know that this Levin's test, when you measure, you have to have your null hypothesis is that the null is that the variances are same, right, variances among the groups, variances are same, right, and alternate is that variances are not same, okay, variances are not same among the group, at least one group is different. Now, surprisingly in this case, since we are saying equal variances between treatments we want it, so we want our null hypothesis to be accepted. That means, if you have your if you want to check your p value, your p value should be less than 0.05, suppose at a 5% level of significance you are checking, it should be less. Generally what we do, we talk that we expect that we always reject the null hypothesis and accept the alternate, but in this condition, this special case, we want that we will accept the null and reject the alternate, that is the condition, right. The error term is normally distributed, right. Okay. So, it is there is a normal distribution of the within variance, right, or the error term. No outliers, significantly big outliers should be, big or small outliers should be there, right. What conditions are required? Dependent variable should be measured at the continuous level, so that is interval or ratio. Independent variable should consist of 2 or more categorical independent levels. Now this is, there should be independence of observations, which I just explained, which means that no relationship between the observations in each group or between the group themselves. For example, there must be different participants in each group with no participant being in more than one group, that means you cannot repeat the participant, right. So that is one of the conditions that you need to check. Now the same case which if you see, go back to this one, the first case, right. So I have tried to draw a small a table. So there are 3 brands of Indian cars, Maruti Swift, Zen Estilo, and this is also from Maruti, and this is a Tata Nano. There are 4 brands of, let us say, tires, MRF, Apollo, Goodyear and Dunlop, and the mileages are, these are the mileages which are given to you, right. So now in such a condition we want to see the effect of not only the tires, right, but the brands, also the brands together on the mileage of the car. Okay. So now when we talk about the n-way analysis of variance or 2-way or 3-way, 4-way analysis of variance, we need to understand some terms. What is that? Now the first is the main effect. So when you are studying the effect of ANOVA, there are 3 effects basically. One, the main effect, the second called the simple main effect, the third is called the interaction effect. First let me explain to you one by one very clearly what it means. First, main effect. A main effect is the effect on performance of one treatment variable considered in isolation. That means what? Ignoring other variables in the study. That suppose there are 2 variables, then you want to see the 2 variables are A and B, you want to see the effect of A ignoring B. Similarly, if you want to see the effect of B ignoring A, it is called that we are checking the main effect of A and B. Okay. Now in the last example, the main effect of car brand, for example in this case we want to see the main effect of car brand, okay, the brand of the car. What is the null hypothesis? There is no difference in average gas mileage across the different brands of cars. So this is my null hypothesis, but I do not want to see that. So what is my alternate? There are differences in average gas mileage across the different brands of cars, or at least in one of these cases, at least there is some difference, at least if there are 3 cars, at least one of them is different from the rest. Okay. Similarly, what is the main effect of the tire brand? You try to write yourself first before seeing this, right. So the null hypothesis is there is no difference in average gas mileage across the different brands of tires, and alternatively the alternate hypothesis says there is at least some difference in the average gas mileage across the different brands of tires. So this you see this. So this is a case where we are taking, suppose we are taking this is a 2 cross simple matrix. So let us say these are my tires and these are my brands of cars, okay, tires. Okay. Now what am I saying? The effect of A, this is A1, this is A2, right. So when I compare the effect of compare between these 2 means, that is of A1 and A2, it gives me the main effect of A. That means if there is a significant difference between A1 and A2, I can say that there is the main effect of A is significant. That means A has a significant effect. Similarly, if I take B, right. So this is the side B, right. So if I take the difference between B1 and B2 and I see whether there is significant difference or not, if there is a significant difference I would say the main effect of B is significant, otherwise I would say it is insignificant. Okay. Now coming to the third term is the simple main effect, which first let me show you what it means. What it says? The simple main effect is the effect of one variable in a multivariable design, in our case the 2 cross 2 matrix, observed at one level of a second variable. Let me show you what it means. Let us see this. Now coming to this, you see there is A1, A2, B1, B2, right. Now A1, B1 is the level of A1 at B1, A2, B1 is the level of A2, the value of A2 at B1, right. Similarly this 4, right. So here A1, B1 minus you see this one, right, this 2 minus A1 B2, this value, this and this, right, gives the simple main effect of B. Why? B is the common of B at A1. Now to understand. So now what you do is you write the simple main effect of B at A2 similarly, right. Let us see. So A2 B1 minus A2 B2 gives the simple main effect of B at where A2. So it is where how it at what level it is playing. So as you go back to the definition, check again, what is it saying? The effect of one variable in a multivariable design observed at a one level of a second variable. So the two variables are A and B, and accordingly you are checking the simple and the main effect. Okay. Okay. Similarly, this gives me the A1 B1 minus A2 B1 gives the simple main effect of A. Now this is A at where? Now B1. Similarly, A1 B2 minus A2 B2 gives the simple main effect of A at where? B2. So these four things are called the simple main effects. Okay. Now coming to another very important term, which is, you know, what happens in real life is that sometimes two variables would be there and individually they might not affect, but when they come together they play a very significant effect. For example, we know that sodium and water, right, when sodium alone is there it does nothing, but and water alone does nothing, but when sodium and water come together they react and it gives a very serious reaction, makes us a very serious reaction. Similarly, there are lots of things. Petrol itself will not do anything, and let us say you put some chemical in that, for example, which can catch fire. So that chemical, when it comes to the close to petrol or, you know, any combustible substance, it gives rise to fire, which can be dangerous. So you have to understand that there are certain things in life and they have a profound effect, which individually they will not do any wrong or any good, but when they come together there is an interaction effect, and that interaction effect plays a very vital role. Now what is this interaction? Let us see. When assessing the relationship between two variables, an interaction occurs if the effect of x1 depends on the level of x2 and vice versa. That means the effect of x2 depends on the level of x1. So at what level x1 is, right, if the value of x2 depends on that, then we say there is an interaction effect. Interactions occur when the effects of one factor on the dependent variable depend on the level of the other factors, right. So let us see this example. So there are two types of consumption habits: people eating cereal, no cereal, coffee and no coffee, right, and this values inside are nothing but a measure of mood quality. So my mood quality is 100, 60, 60, 50, right. So higher the mood quality, better your health condition is, mental health condition is. So what it is saying is, when somebody is consuming cereal and coffee together, let us say, the mood quality is 100. When somebody is consuming cereal but no coffee, the mood quality is 60. When somebody is consuming coffee but no cereal, it is 60. When both is not there, the mood quality is 5. Now if I take the SME, the simple main effect, of cereal, now we are measuring this, you see this SME of cereal with coffee is how much? 40, the SME of cereal with coffee. SME of cereal with no coffee, without coffee, is how much? 10, right. This is 40, this is 10. Now the difference between these two is nothing but my interaction effect, right. So the SME of cereal is larger with coffee than without. Now I want to know whether this difference is a significant difference or not, right. Similarly for this case, SME of coffee is larger with cereal than without. Now is this effect of coffee, is this effect a significant effect or not? We want to measure it. Okay. Now how do we conduct this one way and n-way ANOVA, right? It is very similar to the one way ANOVA which we had done in the last class. Okay. The advantage of the n by ANOVA, like if I had explained in the factorial design, if you remember, is that in the factorial design, in the statistical design or a truly experimental design, randomness is a very important thing. And then when we talk about the interaction effect or the factorial design, statistical design, we said about one of the factorial designs which helps us to make a interaction effect, which was not possible to check in a Latin square design or a randomized design, right. So, this advantage is that it helps you to find the interactions. Okay. How do you conduct? The procedure for conducting n by ANOVA is similar to that for the 1 by ANOVA. The statistics associated are also the same, similar. Let us see. Now, what it is saying? What does SS mean? SS means sum of square, right. So, sum of square total. Now, what is the sum of square? The sum of square is the deviation of any value from some other value which could be the mean, okay. That is what sum of square means. So, sum of square total is equal to sum of square due to the first independent variable, sum of square due to the second independent variable, plus sum of square due to the interaction of x1 and x2, plus sum of square within the group, or this is the error. So, you have I think you have understood by now, sum of square error is also within is also term called as sum of square error. So, since you have now two factors, so earlier you used to have only one factor. So, you used to say sum of square due to x plus some that is x is that is between plus sum of square within, but now since this between has two groups, there are two groups. So, you will say not only due to x1, but also due to x2 and plus the interaction effect of these two, all the three taken. It is very simple, very simple, just understand. So, SSY is the total is equal to x1 x2 x1 x2 plus error. So, this is error, right, within. A greater mean difference in the level of x1 and a larger SSX1 reflects a larger effect of x1. What does it mean? A greater mean difference in the levels of x1. So, that means x1, if there is a that value you saw the difference we showed in the last matrix, right, and a larger sum of square reflects that x1 has got a big impact or a significant impact. Similarly, the same is true for x2. I had shown you in this if you this one, right, I am talking about this slide, right. Larger the interaction between x1 and x2, the larger the sum of square x1 x2 will be, right. On the other hand, if x1 and x2 are independent, there is no relationship, the value of S1 SS sum of square x1 x2 will be 0 or close to 0. That means, the interaction effects does not happen on its own. Interaction effects can only happen when there is some relationship or some connection between the two variables. Had they been completely independent variables, there is no relationship. For example, a living organism and a non-living organism, if there is no relationship, there will be no interaction, right. But if there are two living organisms, maybe one is a fish and the other is human, still there can be some interaction, a dog and a human, a dog and a cat. But what is the interaction between, let us say, a car and a stone? Hardly any, right. So, steps to follow. Step 1. So, how do you conduct this test? The strength of the joint effect of two or more factors or the overall effect is to be measured first. How? Through the multiple eta square. Now, what is the formula? Sum of square of x1 plus sum of square of x2 plus sum of square of x1 x2, right, the interaction, divided by the total sum of square, right. This is the formula how you collect, right, and then you check whether it is significant or not. How do you check the significance? The significance is checked by the f value. So, to do this, what you do is this, you take this formula, a sum of square x1 plus sum of square x2 plus sum of square x1 x2 total divided by the degree of freedom in the numerator divided by sum of square of error divided by the degree of freedom in the denominator. If you remember earlier also the same formula in 1 by ANOVA, it was sum of square between, we were saying, divided by the degree of freedom between by sum of square within by degree of freedom within, right. This is what we were saying, same thing. So, by doing this, by using this formula, you are calculating the mean sum of square, right, of x1, x2, x1, x2 by MS error. Now, you see the degree of freedom for the numerator is given as how much? Now, C1, C2 minus 1. So, there are two variables, let us say you take x1, x2, C1, whatever you x C1 you take row and the other column. So, the total in the number of variables into the number of levels multiplied minus 1. There are two rows, let us say two brands and three tire, let us say three cars were there and 4 tires were there. So, the total was 3 into 4, 12 minus 1, this is what we mean, right. Degree of freedom for the denominator is n is the total number of elements, total number of cells, in fact total number of cells minus C1 into C2, that means number of rows and columns. So, in that case how much we had, I have to check again, anyway whatever it is, the total number minus this C1 C2, right. So, this is how you go. Step 3, once you have found the significance of the overall model, then you check whether there is any interaction effect or not. Now, why this is important? If there is an interaction effect of the interaction effect, then understand that main effects, the effect of the main effects do not play any vital role, right. That means, if there is no interaction effect, then only one should go for checking the main effects. Okay. Now, what is this? If the overall effect is significant, the next step is to examine the significance of the interaction effect. Under the null hypothesis of the f test is how do you check the interaction? The f is equal to, through the f value, the interaction, this is the interaction sum of square, right, divided by the degree of freedom of the numerator and sum of square within degree of freedom denominator. Now, you see what it is saying, degree of freedom numerator is equal to C1 minus 1, the row minus 1, column minus 1, same thing, right, and this is again the you do it. Now, once this is done, you get a interaction value, right. Now, after this, suppose the interaction you have done and then you check, you want to check the main effects. Generally main effects should be only be checked when the interaction effect is insignificant. Let us read this. If the interaction effect is found to be significant, then the effect of x1 depends on the level of x2, right, and vice versa. Since the effect of one factor is not uniform, but varies with the level of the other factor, it is generally not meaningful to test the significance of the main effect of each factor, right. That means what? If it is if the interaction effect is significant, it makes no sense to go for checking the significance of the main effects, because it has been seen that the level of x, the value of x1 depends on the level of x2. So, that means their position, according to their position, the output depends. It is meaningful to test the significance of each main effect of each factor only if the interaction effect is not significant. So, this is the thing, this is very important. Suppose you found it is not significant, then you can check the significance of the main effect of each factor. So, there are two factors x1 and x2, for example, I am showing you for x1, similarly you do for x2. Okay. Now, f is equal to what? It says the sum of square of x1. So, since this is for x1, divided by the degree of freedom divided by the sum of square error by the degree of freedom, where degree of freedom is, this time it is, why it is C1 minus 1, because only we are talking about one factor. So, there is no second factor. So, there is only one minus from the same factor. So, whatever the C1, the number of levels, C1 the number of levels. So, there are 3 levels. So, 3 minus 1, 4 levels, 4 minus 1, whatever it is, right. I hope you are pretty clear with it now. What is one way ANOVA and what is the meaning of an analysis of covariance, which is ANCOVA, and what is a n-way ANOVA, and how do you calculate by hand and how do you do it through SPSS. I will show you in the next lecture. So, I hope you enjoyed this lecture, and maybe in the next lecture we will be little more you will learn how to do that and have a little more grasp on the subject, right. So, thank you very much.